Trigonometry often appears as a wall of complex equations, but fundamentally, it is the study of how three sides of a shape relate. In the next 5 minutes, you will calculate all 6 trigonometric ratios from scratch. You will do this using a visual pattern rather than a list of memorized formulas. Look at this diagram. By the end of this tutorial, you will be able to map out these side lengths and write out all 6 of these equations yourself. To follow along, grab a pen and a piece of paper right now. We are going to build your own cheat sheet. Learning this visual pattern replaces rote memorization with simple observation. Let's establish our framework. This is a right-angled triangle. Note the 90-degree angle here and the symbol resting in the bottom right corner. That is theta, and it represents our angle of interest. First, locate the anchor point. The hypotenuse is the side locked directly opposite the 90-degree angle. Next is the perpendicular side. This is defined as the side sitting directly opposite your theta angle. Finally, locate the base. This is the side that physically touches our theta angle. It is important to note that the base is not always the physical bottom of the shape. If theta moves to this top corner, the perpendicular and base labels swap positions to maintain their relationship with the angle. In trigonometry, the identity of a side depends entirely on the perspective of the theta angle. We can translate these 3 sides into our primary trigonometric ratios using the Pandit Badri Prasad mnemonic. On your paper, write the first row of your cheat sheet, Pandit Badri Prasad. Directly beneath those words, write Har Har Bole. This creates 3 vertical columns. We label these columns using the rhyme Sona Chandi Tole, which gives us our headers, Sin, Cos, and Tan. Now strip away the excess letters and draw a division line between the rows. You have the formulas for sine, cosine, and tangent. This grid organizes the foundational equations for you. Sine is perpendicular over hypotenuse, cosine is base over hypotenuse, and tangent is perpendicular over base. The final 3 ratios, cosecant, secant, and cotangent, are the inverse of the first 3. You can find these new ratios by flipping your existing fractions upside down. To find cosecant, take your sine fraction, perpendicular over hypotenuse, and invert it. It becomes hypotenuse over perpendicular. For secant, flip your cosine fraction to get hypotenuse over base. And for cotangent, flip your tangent fraction to get base over perpendicular. By using these 3 primary fractions and their inverses, you have every tool needed to define the properties of this triangle. Let's apply this to a triangle where the perpendicular side is 5 and the base is 12. Before we can list our 6 ratios, we must find the value of our hypotenuse. We use the Pythagorean theorem and substitute our known values, 5 squared plus 12 squared. 5 squared is 25, and 12 squared is 144. Together, they equal 169. The square root of 169 is 13. Our hypotenuse is now identified. Now we plug these numbers into our mnemonic formulas. Sine is 5 over 13, cosine is 12 over 13, and tangent is 5 over 12. To complete the set, we flip those 3 answers. Cosecant is 13 over 5, secant is 13 over 12, and cotangent is 12 over 5. Starting with just 2 side lengths, you used visual logic to find every trigonometric property of the shape. You have gone from looking at an unfamiliar concept to breaking it down piece by piece. Look at this notebook page. This is the same structure you can now generate for any right triangle. To avoid errors, always check that the perpendicular is the side directly opposite your theta angle. Keep your cheat sheet ready and put this framework to use on exercise 8.1. Once you have the mnemonic matrix on your paper, calculating these ratios becomes a matter of simple substitution.